Hey everyone, welcome back to The Explainer. Today we're unpacking a chapter that is honestly just so fascinating. We interact with this stuff literally every single second of the day, but how often do we actually stop to appreciate the hidden math and geometry of our world? We're going to take a journey from some beautiful everyday cultural art all the way to the strict rules of shapes and then cap it off with some interactive spatial puzzles that'll really test your intuition. Let's get right into it. Here's our quick roadmap for today. 1. Art meets mathematics. 2. Defining the rectangle. 3. Hands-on shape-shifting. And 4. Spatial puzzles and play. Section 1. Art meets mathematics. Geometry in culture. So let's start by looking at this scene of Amma creating a gorgeous Rangoli on the floor. Now, a Rangoli is a traditional Indian art form where these super intricate patterns are made using stuff like colored sand or flower petals, and they're usually guided by a grid of dots. By starting our explainer here, we're taking abstract math and anchoring it in a totally familiar, highly visual practice. You know, math isn't just locked away in textbooks, it's literally right there in the traditions inside our homes. But watch what happens when we zoom in on the Rangoli. The art suddenly transforms into a strict mathematical grid. Those dots, they act exactly like a coordinate plane. I want you to kind of transition your mindset right now. Move away from just appreciating the art and start observing the math. Notice how the different colors highlight specific, discrete shapes that just interlock perfectly together. Let's get a bit interactive with this visual data. Look really closely at the Rangoli pattern. How many of those shapes are built using curved lines, and how many rely completely on straight lines? It's kind of like a giant puzzle, and we're breaking this complex image down into its absolute fundamental properties. Okay, so here's the breakdown based on what we just observed. The blue circles are outliers here because they're the only shapes made with continuous curved lines. Literally everything else, the orange squares, the green triangles, the red and yellow nested diamonds, they are all constructed entirely out of straight lines. So just by observing some floor art, we've managed to categorize geometry into two totally distinct camps, curved and straight. And check out our friendly animated pencil pointing the way here. It's a great reminder to keep a playful, curious mindset. We aren't just memorizing facts from a chapter, we're actively investigating. So let's transition from those broad categories and start building some specific, unbreakable rules. Section 2, Defining the rectangle. Rules of the shape. Now, a rectangle isn't just some stretched out box, right? It actually has very strict mathematical criteria. It has to be a closed shape with exactly 4 sides and exactly 4 corners. But here's the real kicker, the absolute defining characteristic. The opposite sides must be completely equal in length to each other. If a shape doesn't check all those boxes, it's just not a rectangle. No exceptions. I really want to drill down on this number 4. 4 sides, 4 corners. This is the absolute foundational rule for the whole family of quadrilaterals, which, of course, the rectangle belongs to. Whenever you're evaluating a shape to see if it fits the definition we just talked about, your brain should immediately start counting the 4. Notice the teacher's prompt here. Describe the shapes in your own words. It's really not enough to just parrot back a textbook definition. You've got to internalize it, look at the shape, see the rules in action, and explain them yourself. That is how you build true, lasting understanding of the chapter's concepts. And this comparison perfectly illustrates how those rules apply in the real world. On one side, we have a completely mundane, everyday object, a flattened cardboard box. On the other side, that abstract Rangoli grid. The crazy part? The exact same geometric rules, those 4 sides and equal opposite lengths, apply just as much to your recycling bin as they do to traditional art. Geometry is literally everywhere. Section 3. Hands-on shape-shifting. Mathematics in motion. Let's look at a totally practical exercise from the chapter, making an envelope. You start with a square piece of paper, which, as we know, is a shape with 4 equal sides. But watch what happens when you fold the opposite corners to the center line, then fold the bottom point up and the top flap down. By doing that, you are fundamentally altering the geometry of that paper. It's amazing seeing abstract steps become completely concrete. Look at that second stage of the fold. By folding just 2 corners of the square, we've created an entirely new 6-sided shape, a hexagon. And right inside that hexagon, we can clearly spot 2 distinct triangles formed by the folded flaps. We are physically manipulating one shape to construct a whole combination of new ones. So here's a fun conceptual question for you. Can you fold all the corners of a square sheet of paper in such a way that the total number of corners remains exactly the same? This really pushes you to visualize transforming a square purely in your mind. Usually, if you fold a corner inward, you end up creating more corners, right? So how on earth you fold it to keep exactly 4? It's a really fantastic test of your spatial reasoning.
Section 4, Spatial Puzzles and Play, Testing Your Intuition.
Imagine a rectangle made out of grid paper, but it's got jagged, torn edges missing from it. The big question is, how many square pieces have been torn from the shape? You can't just count what's physically there anymore. Instead, you have to mentally project that grid into the negative space and visualize the invisible geometry to solve the puzzle. It's kind of tricky, right? Next up is this cool tangram-style exercise. If you cut a square along the dotted lines, so you have 4 distinct triangles, try taking just 3 of them to see how many entirely new composite forms you can make. It just goes to show that complex shapes are really nothing more than simple shapes stacked together, just waiting to be recombined. All right, now for a genuinely tricky one. If you're given a composite shape, can you draw just one straight line to split it into exactly 3 triangles? What if you use 2 lines? This forces you to look at a larger polygon and hunt for those hidden intersecting points that will slice it perfectly. It is pure, unadulterated problem solving. We can even turn all this spatial awareness into a game. Grab some dot paper. One person draws just 2 opposite vertices, basically 2 opposite corners, and the other person has to figure out how to complete the rest of the rectangle based strictly on those 2 points. It's such a great hands-on way to test what we've learned. And that brings us to the end of today's explainer. We've successfully bridged the gap between everyday life and strict mathematical rules, using everything from floor art to folded paper to spatial puzzles. Honestly, unpacking this chapter completely changes how you look at the world. So my final question for you is this. The next time you break down a cardboard box, or admire a patterned floor, or even just fold a letter, what hidden shapes will you see? Thanks so much for hanging out and learning with me today. Keep your eyes open and keep exploring the math all around you.